Before I begin, I want to thank Numberly for giving me the opportunity to talk to you today. And speaking of Numberly, I'd like to introduce you all to Othman, the head of data and AI at Numberly.
So I'm the guy that's gonna present the company and then hand over to him. So Numberly, we're a French company. We're known for our door. If you end up going to Paris, we're the only building that has that color for the door that goes with our company colors. What do? Actually, we do marketing technology. So it's all about CRM, loyalty management, going from bringing all our clients' strategic marketing or strategic view to life through technology. And couple key figures. So we're in Paris, as I said. The headquarters in Paris. We're actually in more countries than that: Brussels, London, Amsterdam, and so on. I'm based in San Francisco. 95 of our infrastructure is on-premise. We're old school, so we still have those bare metal servers, and we love them. We are our own internet service provider, so we actually route and send messages, like critical messages for services. So we need to have that guarantee for our customers. We commit to a lot of open source projects. We are 11 years in a row or Python sponsors, and we self-host our Airflow since 2017. Couple figures: we have more than 1,800 DAGs in production on 2 instances. I've been hearing a lot of scaling over here, so we've been in a lot of trouble in that. 341 data sets. I see a lot of people that spoke about data-driven and event-driven processing. We've been doing that for long. And you see the figures: 16K daily runs and 44,000 tasks. So it's a lot to handle. And from that, with those beautiful figures, I'm going to hand over to Seb.
Thank you, Othman. So before I introduce the subject, let me introduce myself real quick. So my name is Sébastien Crocquevieille, but you can just call me Seb. I'm a data engineer from Numberly, of course, and I'm French and Mexican. I've been an Airflow user since 2018 and had the pleasure of giving 2 talks about Airflow, one at EuroPython and one at PyCon Taiwan. And we're going to get right into it and talk about events and asset scheduling. But before I begin, here's a little bit of a disclaimer. This is a personal opinion, personal interpretation, and it has served me well, but at the end of the day, it's subjective. So if you want to talk about it, we can talk about it after the talk. So let's start with external events. What is an external event? Well, an external event could be just about anything. Usually you think about messages and posts, but it could be a change in a value somewhere. It could be any detectable action or signal. Like imagine if the ISS were catching sun flares and then emitting radio signals. That would be an event. And so because we have such diversity in terms of events, we have to be a little bit more strict in event-driven scheduling. So in event-driven scheduling, you want your execution to directly mirror your events because you probably want some individual action based on the payload. That means that you have to have one-to-one execution. You do this through an asset watcher, and you probably have to, if you define it yourself, ensure deliverability, avoid duplicates, and maybe you even care about ordering. So you have more strict requirements because you have such a variety in your events. And this directly differentiates you from asset-aware scheduling, where here your events are very similar. You're looking at a single data source and you're looking at changes in that data source. And so when you want to, for example, refresh a table, you don't care how many different events have caused that source to change, because if you insert, delete, insert, at the end of the day, the source either has changed or has not changed. And you only need to do the refresh action once for however many events you want to consume. So you don't have one-to-one execution, contrarily to event-driven scheduling, and you don't care about the order of the events. You just care that if it has changed, I need to refresh. Also, you don't use triggers here. We just use Airflow assets. And that's another thing I've been wanting to talk about. A lot of people define assets in very different ways. I'm going to be very strict here and tell you an asset is a string. It's just a string. You put it in your DB, and that's all it is. Now, that string represents a data source that exists somewhere out there in your data warehouse or maybe in a database management system. But all you store is the string. Maintaining the link between the string and the data source that exists out there is your responsibility. That means that if your DAGs are changing your data source, you need to update the data set. But if something outside of Airflow is also updating that source, you also need to update the data set via the Airflow API. Finally, assets are generated by DAG parsing. That's important, and we'll see later why. So now we've talked about scheduling a little bit. Let's talk about upscaling our scheduler. We're going to go through this part a little fast. If you have questions, you can come to me at the end. But basically, the Airflow scheduler, you all know, it's the most important part of Airflow. It's the one that monitors all your tasks and DAGs. It's the one that triggers the DAG execution. And the first thing you want to do if you have performance issues is look at the machine. Does it have high CPU and RAM usage? Is your scheduler's heartbeat beating? If it's not, it's probably swamped or blocked. Is the DAG parse time slowing things down? From a more holistic view or from the UI, you could say, do I have many tasks that are queued or scheduled? And if you arrive after those queued tasks have been finally processed, you'll be able to notice that your DAG runs have been delayed. Finally, Airflow is well known for being database connection hungry because the more DAGs you have, the more processes you run or you run in parallel, the more connections you'll be opening, and it's usually the final boss in terms of scaling, usually due to too many connections or massive tables that cause slow queries. So the first thing you do is you start to have remote executors, like the Celery executor, the Kubernetes executor. What you're doing here is you're decoupling your workers from your schedulers, probably running them in the cloud somewhere. This is great because you now can run your workers much more in parallel. You're not limited by the machine or the pod where your scheduler is working. And in the modern day, in the cloud, you generally have low latency workers available whenever you want. But you either have to set it up yourself and it costs blood, sweat, and tears, or you have to rent it from your cloud provider. So you need a cluster either way, so pick your poison. If you do this and you're still having issues, well, you might as well start replicating your scheduler. If one scheduler is not enough, why not 2, 3, 4? And this is fairly easy compared to the previous solution. This just requires you, if you're on Kubernetes, to set your replica to 2, and if you're not, to just spawn another process. It's very nice. It splits the load. If one scheduler dies, you still have the other one, and it doesn't cost you much work, but it does increase your database operations a lot. And if you've done both of these things and you're still having problems, well, the database is the problem by now. So at this point, not much you can do except just, have 2 Airflows. This is nice because, you've reached the peak of scalability. If you have scalability problems, just have more Airflows, 2, 3, 4, 5. Like I saw a guy the other day with a talk. He said he had 10 Airflows because of his 10 teams. And I mean, sure, more is not always better, but why not? This is nice because you get a few bonuses along the way. Like you have separation of concerns. Maybe you have an instance that deals with highly critical things and another instance that deals with not so important things, and you can treat them differently. And a lot of people seem to love splitting their instances among teams. That way they don't have to share connections. They don't have to share access rights, that kind of stuff. That's not necessarily our case at Numberly anymore. We tried it. We didn't like it. And I'm being very sweet with this, but just having 2 Airflows isn't that simple. It's a lot of work. You have to dedicate more resources, which probably costs you money. And at the end of the day, when it's time to migrate, you're going to have to migrate twice as much. So, think it twice before you do it. So now that we've talked about assets and we've talked about multiple instances, if you have both at the same time, well, you're in the perfect position to talk about today's talk, how to synchronize assets among multiple instances. So let's take a look at Numberly's use case. In Numberly's case, we're doing a migration from Airflow 2.4 to Airflow 2.10. And we're doing a complete dependency overhaul while we're doing it. We're moving from Python 3.8 to Python 3.10. We're moving from Spark 2 to Spark 3. And we have a huge library of like 2,000 DAGs that we need to adapt to this process. So to do this, we're spawning a new instance, which is already in the desired version with all of the desired dependencies. And we're migrating our DAGs code and upgrading it as we migrate. We do this based off of batches of DAGs, and we prioritize, whichever DAGs are least complex go first, whichever DAGs have the fewest dependencies go first, and if they need 2.10 features or if they urgently need to be migrated, they also go first. Then we learn lessons from hitting the wall and suffering, and we use those lessons to make the following migrations easier. Some of the things we've developed along the way that we've done this is we now have a DAG trigger operator that runs from one instance to another, so we can trigger DAGs across instances. We now have a sensor that checks for tasks across instances, so we can do that as well. And when we migrated our first DAG with assets, we were like, well, now we have to deal with asset synchronization. So in this talk, we'll be checking about two types of asset synchronization. You either push into Airflow or you pull. We'll start with push. So the interesting thing about push is that you can just detect when you have new events and only push to Airflow when you have new events, and that way you bother Airflow a little bit less. So let's get started. The first thing we do is you want to get your asset events out of Airflow before you put them back in the other one. So you have in Airflow 2 the datasets/assets endpoint, and you can just ping that one and get whatever you need. It's important that when you do this, you filter by minus timestamp, which will give you the newer events first, and then you store the offset of your last consumed event is somewhere you can easily get it. We did it in the Airflow variables. That way, the next time you consume, you only check for asset events that are newer than the last event you consumed. Then once you have your asset events, well, you're going to want to put them somewhere. So I put them into a Kafka topic where we have replayability, which is nice. And now that I have all the asset events from all of my instances in a single place, I have a single source of truth for all my asset events. What's interesting to see here is that the velocity of our data is not that high. We probably get about like an event a minute, maybe a little bit less than that. And this is important to keep in mind whenever you're dealing with data. You want to know, what's your volume, what's your velocity. So we're going to use this later. So we took all our assets, we put them somewhere temporary, and now we just need to put them back in the Airflow. You could say we're about 2/3 of the way done. Sounds great. This is where the issues happen. So the first thing we encounter is, remember we're migrating from 2.4 to 2.10? Well, there's no post endpoint for dataset events in 2.4. So I can't feed back my dataset events to my 2.4 instance, at least not natively in Airflow. But this is easy. I just get a quick and dirty DAG that accesses the Airflow session and directly force pushes them into the database. I can do this because we're migrating away from this. This is a temporary bandage solution. And honestly, I don't have much of a choice. So I just do this. It works for now, and we'll keep it that way. But even on the 2.10 instance, if I have dataset events and I post them to the dataset event endpoints, if the data asset or the dataset linked to them doesn't exist, it's not going to push. It's going to give me a 403. And this is due to something, a little bit of an advanced Airflow concept, is that you can have conflicts between parsed objects and created objects. Your datasets are parsed from your DAGs. They only exist in the database as a reference to whatever your DAGs create. But the dataset events entry in the database is a first-class citizen. That is your dataset events. So you can't really create datasets via the API, at least not in 2.10. This is solved in 3 with the materialize endpoint, but this basically kind of under the hood just makes a DAG that creates your data assets. And the problem with solving it this way is that you still have to call a separate endpoint to create them. You can't just feed all your dataset events and be done with it. So I basically copied the solution, made my own materialized DAG, and I just ping it via the API. Finally, if you're in 2.9 or less, you actually can't really use this solution because datasets can't be created dynamically at runtime. You have to define them in the code. You have to directly code them. This is solved in 2.10 with the dataset alias, and that's actually the reason we're in 2.10. At the time when we decided to migrate, 2.10 was the latest version, and we usually migrate to the latest version -1. But here we were forced to go to the latest version because I desperately needed this feature. So now I have 3 different ways to push to Airflow, but I can finally push my dataset events to Airflow. So this is the final design of my solution. I spun up a service in Kubernetes that basically makes some producers, 1 per Airflow instance. It grabs all the data asset events, it pushes them to the Kafka topic, and then my consumers listen on the Kafka topic for new events and push them with my database editing DAG in 2.4, with the post endpoint if the asset already exists in the 2.10 Airflow, and if the asset doesn't exist, then I just push them to my dataset alias DAG, and it will trigger the dataset event for me. A few things to keep in mind that we needed to do to ensure we don't get issues. First of all, before pushing to Airflow, I only want the newest and freshest events. If I get multiple events twice, 3 times, I will only push the newest one because as we've seen before, you don't need multiple times the same asset. You just need the freshest. So that ensures that I push less things, and I also push the new assets that I find. And finally, if I create an asset event on Airflow A, and then I push it to Kafka, and then it arrives on Airflow B, it'll be detected as a new asset event, and then pushed to Kafka and back to Airflow A. And so to avoid infinite ping pong, I have to make sure that I only push events that are native from that Airflow. So I have to keep track of which events were produced in which Airflow and not push them back to that Airflow. So this is the type of information I'm tracking for each asset event and pushing. The only ones I actually use are the URI, the timestamp, and the URL. The rest is not useful for me, but I think it's useful to keep an idea of what's the lineage of an Airflow event. That way, wherever it ends up, I can still, find out how it was produced and keep track of that. And I don't know, I'm not anticipating all the future uses for this, so I just want to make sure I have all my bases covered. And voila, it works. And now all I have to do is monitor this and keep maintaining it until the end of time. But the good thing about this is that it's not a very resource-intensive solution. So that's good because we scaled Airflow because we were having performance issues in the first place. Now let's look at the pull solution. In the pull solution, we'll be using event-based scheduling to constantly pull the Airflow events and make sure they're up to date. So for this solution, I'm going to need you all to suspend your disbelief. Right? Imagine that all is good in my company and we're in Airflow 3, so we have access to this. So what we're going to do is we're going to define an asset watcher, asset events, and trigger DAG execution with this. So I had a part about coding this together, but Vincent Beck's talk and Andrea's talk already touched on this, so I'm going to speed through this at lightning speed, and if you want to talk about it, we can talk about it at the end. So if you want to do event-based scheduling, you need an asset watcher. The asset watcher needs a trigger. The trigger needs an instance of a base event trigger class or a class that inherits from it. This class basically has three important methods. It needs a constructor, it needs a serialized method, and it needs a run method. So here I'm going to assume that all I need to get my data asset events are URL. And that's all I'm going to put in my constructor. One thing that I do actually want to touch on is the serialized method, because I've seen it in a lot of talks, but no one has properly explained it, I feel. So the serialized method is a tuple, and it only takes two things. It takes basically the path that you would need to import your class from in Python, and it takes a dictionary with all the information you would need to be able to call the constructor. The reason for that is because the first one gives you the location of the class, and the second one gives you all you need to recreate the instance. And so you can store a string and a JSON into a database, and you can keep it back. Okay. And you can reuse it whenever you want. You can't really store Python objects, but in this way, you can. And that's basically what serialization is about. So then you define your run method, and you get your events, and then you yield a trigger event every time you have one. And we define our asset with that, and we define our DAG with that asset, and boom, we have trigger events. Remember earlier how I told you that it's important to care about the velocity of our data? So here I have between 2 to 10 trigger events every millisecond, but I'm producing a data asset every minute, more or less. So if I were to actually implement this in real life, I'd have to do something about that disconnect, or else I'd be wasting resources. Finally, it's important to note that the only existing event triggers that are available out of the box are Kafka and a handful of others. For the rest, they're just base triggers. They're not base event triggers, so they won't work. So if you want to do pull-based scheduling, you need to implement all your business or technical logic in the run method, like error handling, pagination, authentication, since we're pulling an API. And you can't do any blocking or heavy operations. You also need to know what's the status of your trigger. At Airflow, we don't use, at Numberly, we don't use deferred operators yet, so we don't actually have one. And if you do have one, you need to worry about whether or not it's sapping resources from your scheduler. So this might have left you a little bit confused, like can we pull or can we not pull? Well, if you remember the schema of our push solution, there's something really nice in the center of it. It's called Kafka topic, and there is an available, what did I call it? Yeah, there is an available Kafka message queue trigger, so we can just, very, very easily use event scheduling to replace the consumers on our push solution and just directly get our messages from Kafka. But I mean, if I'm gonna, use pull, I'd rather just pull the whole thing and just directly replace my solution, so I don't have to maintain anything and just use Airflow out of the box. So with the queue, I have to worry about the polling, and I still need to push to the queue, so I can either keep my service or I can try a hacky solution where I use a bunch of always on DAGs to always push my data asset events to the queue. But I wouldn't be very satisfied with that. And without the queue, I've thought about it, and you probably can use a mix of API requests inside your run method and Airflow variable calls to only get the newest events. But the problem with this is that when you remove the queue, every Airflow has to ping every other Airflow. And so instead of having N calls and another N calls, you have N calls for every Airflow. So that's a lot of network calls, especially when you remember the frequency at which the trigger is running, and nobody likes to deal with network issues. So if you ask me for real, do I push or do I pull? My answer to you would be, I don't care, I'm still on Airflow 2. The choice is yours. Thank you very much.